Okay, today's learning goal, we're going to be looking at ratios, rates, and proportions. So by the end of today, I'll be able to recognize the difference between a ratio and a rate. I will be able to change the setup of a ratio, and I will be able to recognize and solve a proportion, which is two ratios that have been set equal to each other. So just to make sure we're all on the same page, ratios compare quantities with usually the same units or no units at all, and it would look something like this. This is a ratio. A rate shows how one quantity changes with respect to another. Usually they have different units, but not all the time, but something like that is a rate. And a proportion is an equation that states two ratios or rates are equivalent. So this is a proportion. The ratio of cats to dogs in a pet store was 14 cats to 16 dogs. So this ratio can be expressed in a number of different forms. I find it very handy to write little notes underneath some of the numbers because it's easy to lose track. So 14 cats and 16 dogs. It just lets me keep track of which one's which. So you can use the word two, you can use these two little dots or a colon in between, or you can write it in fraction form. And what we'll find usually is fraction form is actually very helpful, especially when we have to solve different types of proportions. A rate is recognizable because it usually has different units. So for example here we have kilometers on the top and hours on the bottom. A unit rate, and this is a big one to know. Okay, a unit rate is created when we actually perform the division. Okay, so when we do that operation, we end up with a 1 in the denominator position. So for example, if we had 200 kilometers traveled in 4 hours, if you do that division, that gives you an answer of 50 kilometers for 1 hour. And this is a unit rate. And it's really handy when we want to compare things. So if we reduce rates to their unit rate, it allows us to compare a little easier than if we just dealt with the original information. A ratio, like a fraction, can be expressed in lowest terms. So if we have a ratio of 4 to 8, we can express that in the lowest terms of 1 to 2. Okay. We can also express our ratios as fractions. So there's a little bit of pattern watching you have to be careful of here. So I'm going to take this 4 to 8 and I'm going to rotate the 4 above the 8, which means the 1 rotates above the 2. Now that isn't the only way to do this problem. You could also rotate the 4 under and then you would have 8 to 4, but it wouldn't be equal to 1 over 2, it would be equal to 2 over 1. So as the solver, you get to choose how you set up that converting from a singular line to the fraction form. Okay, so that's up to you, but you have to make sure you're consistent in that if you move the first term above, it has to be done with both of those. Okay, so when we have this equal sign, this is what a proportion is. So two ratios that are set equal to each other. So when we have something like this, so solving proportions, so we've had this little box or missing element before, right here. Okay, and we found that it's much easier to work with some of these problems when we put in a variable. So in this case, I just put an n. Okay, now some people will have done these types of problems and they'll use arrows and they'll look at this and go, what gets me from here to here and what goes from here to here. And that's completely acceptable, but I'm going to try and take you to a place where we use our simple equations and our fraction forms a little more often, just because it tends to be a little bit more powerful and avoids some of these little silly mistakes. Okay, I'm just going to change that to an equal sign there. That was just two little dots. So if I have 4 to 5 equals n over 35, we can use our simple equations knowledge to try and isolate that n value. So I'm just going to write it again a little bit bigger so I can write a little easier on it. So now if I want to get this n by itself, I want to undo or cancel out a dividing by 35. So we're going to multiply both sides by 35, just like we would do in our simple equations. Okay, so these would cancel. I'm left with an n, and now I just have to solve, and if you need to, put the placeholder in here. 35 times 4 divided by 5. Okay, so I can see here that 5 goes into 35 7 times, so I'm going to shrink this number before I even start, and then 7 times 4 is 28. So the missing number here that is part of my proportion is actually a 28. Okay, so when we do this, we want to watch the setup into fraction form. So you can do this two different ways. So in this, you'll notice in the first version here, I rotated the 7 over top of the 8 and then the 21 over top of the 8, which is completely acceptable. It will work. There's one problem. You've put the unknown in the bottom location. And you can solve this, but the algebra is a little trickier. The other option is rotate the 7 down below the 8 and the 21 down below the 8, and you'll put your variable in the top location, which is where we want to actually have it. Okay, so if you do it the second way, this is the preferred way, you only have one step to solve to figure out what n is, and that's getting rid of the dividing by 21. If you do it this method over here, you have to get the n out of the bottom first, which means multiplying both sides by n, and then moving a whole bunch of numbers around using your opposite operations. And I'll gladly show you that, but I'm going to leave it out for now just because it's more confusing. We want our n, or our variable, in the top position. That's our goal. Okay, so ratios can be rearranged to help us solve for the missing value. So you'll notice the n here is in the bottom, and we're going to try and get it out of there. Well, if I rewrite this ratio, so I bring this n up to the right side of the 72, that means the 7 is going to do the same. So you'll notice 9 to 7 is equal to 72 to n. Okay, and then I'm going to bring the n over top of the 72, which means the 7 goes over the 9, and that's the ratio we end up with over here. And most of you, I think, when you stare at this, won't write out these steps. You will simply take this one and you'll flip both terms. And the key is you have to flip both. Okay, but I wanted to show you why it works, what the understanding is, so you're not just magically flipping things and hoping for the best. Okay, so you're actually just changing forms, and that's why you can do that. Okay, so pause it here, and if you can solve for the unknown value of x, that would be great. So just pause now, please. Okay, so I'm going to set this up. So I want to make sure I get my x into the top location. So I'm going to draw little arrows to remind myself what I'm doing. So I'm going to put 5 over 9 is equal to x over 81. Now all I need to do is get the x by itself. So I need to get rid of this dividing by 81. So I'm going to multiply both sides by 81. And these will cancel. So now my x is by itself, which is what I wanted. Okay, and now on the left-hand side, if I have to, I could put a placeholder in underneath that 81. Now I could multiply 81 times 5 and then divide all that by 9. That will work just fine. I'm going to make my life a little bit easier. I'm going to do this division of 81 divided by 9. So these guys here, when we divide them, we end up with 9. Okay, and then all I'm left to do is multiply 9 times 5, and I get the answer of 45. Okay, which is the value of x. Now we can do this with decimals as well. Don't panic. We simply set it up the same way. Okay, so I'm going to rotate the x over top of the 22.2. I'm going to rotate the 2.1 over the 7.4, and then I'm going to look at this right-hand side and say what eliminates or cancels dividing by 22.2. Well, multiplying by 22.2. So if I multiply both sides by 22.2, these guys would cancel, and I would left with an x on the right hand side, which is the isolated variable I want, and now I just have to do the calculations. And if you're not comfortable with decimals, that's totally okay. This is where you'd grab your calculator, and you can put your placeholder in here if you need to. 22.2 times 2.1 times or divided by 7.4 and see what your calculator gives you. I'm kind of comfortable with my numbers. I know that 7.4 goes into 22.2 3 times, and then 3 times 2.1 is 6.3. Okay, so you don't have to panic just because they're decimals, it's just a different number. Okay, so rates. If you were eating 14 bananas a week, so if you looked at that, 14 bananas every 7 days, you would have a unit rate of 2 bananas a day. Okay, that's just just the way it averages out. So some rates make more sense than others. So if we're traveling 120 kilometers in 2 hours, so about the distance to Nipigon, so if we traveled that in 2 hours, our unit rate would be 60 kilometers an hour. And this is generally fairly comfortable. However, we don't have to do our rates that way. We could put the unit of time on top and say our unit is 2 hours every 120 kilometers. And it would be correct. It just might not feel as comfortable because you don't hear it as often. And then if you found the unit rate, 0.0166 hours every kilometer. Again, it's completely correct, but it's just not familiar to us. So we tend to set up our rates in certain ways that have familiarity. Okay, so now the last part is something called the total number for a ratio. Okay, if we investigate a gym class that has 12 basketball players and 14 volleyball players, we can write a ratio of 12 to 14. So I might put a little b under here and a v under here just to keep track of which term is which. The total number of athletes, okay, in the class is the sum of the number of basketball and volleyball players together. So if we add those two values together, we get the total number of athletes in this class. It doesn't always have to be athletes, it could be whatever objects you're talking about. So if we were asked what percent of athletes in the class are basketball players, we could then investigate the percent calculation arising from, right here, 12 out of 26. Okay, so if we were going to do 12 out of 26, again, this is a great time. You can use your calculator if you like. Good use of it. 12 divided by 26, we would get 0.46. And just as a refresher, to move from a decimal to a percent, and we'll be doing this tomorrow, but just a little precursor, you would times it by 100, and you would come up with 46%, which makes sense because 12 is just about half of 26. Okay, so you have a task for ratios, rates, and proportions. Thanks for tuning in. Enjoy.